James Webb Space Telescope is a product of decades of hard work from scientists around the world.
I have been waiting my entire astronomy career for JWST. It is absolutely revolutionary compared to what was available.
It's very, very rare in science that you make a big step forward in your measurement capability in the way that JWST has done for astronomy. And it just doesn't happen very often in the history of science, and that's really exciting and significant.
One of the things that makes James Webb so special is its gigantic mirror.
So that there are various things that make the primary mirror on James Webb special and incredible. I mean, the first is the sheer size of the mirror. It's the largest one ever launched.
The Webb mirror is around 6.5 meters in size. So if you can imagine that, that's bigger than most houses you're walking by.
It's so large it wouldn't fit in the rocket, so they had to devise a way of folding it up so that it would fit inside the top of the rocket.
It's absolutely humongous. And that makes a really big difference in terms of the sensitivity of the telescope.
Well, it's thousands of times than Hubble step forward of factors of thousands. Factors of 7,000.
The bigger the mirror, the more light you collect. The bigger the collecting area, the more sensitive you are, and the further you can see.
The precision with which it's been made. If the mirror was stretched to be the size of the United States, and you were to measure the size of the biggest bumps and dips on the mirror, you're only looking at a bump or a dip of 1 centimetre in size. It's absolutely incredible, and that's what generates the near-perfect images from the primary mirror.
But it's not just the mirror that makes the images from James Webb so incredible. It's also the type of light that it detects. The James Webb Space Telescope detects infrared light, which is a wavelength of light that we can't see. But the unique properties of infrared make it incredible for exploration.
So with the infrared light, you can see the atmospheres of exoplanets, molecules in star formation regions, things like alcohol and water ice, the signatures of life around other planets.
So just a few things then. Infrared opens up the possibilities for astronomers like Olivia and allows them to capture images that would previously be impossible in the optical range. But even within the infrared spectrum, there are multiple different wavelengths. On board Webb, there are 3 instruments that observe near infrared. This is closer to the visible spectrum. But the instrument that's garnering the world's attention is the mid-infrared instrument on board JWST, known as MIRI.
MIRI is essential for JWST. Without it, you can't see the cooler phenomena in the universe. You can't peer back into the earlier stages of star formation as you would like.
So MIRI is an incredibly significant and important instrument. The images contains far more detail than has ever been done before.
When we look at it in a new wavelength of light, we find things that we hadn't expected to see, and that's a really important part of how you discover things about the universe.
MIRI allows us to see further along the infrared spectrum, and this in turn